Hi. So we want to understand perception of different perspective, comparison between TSV versus PET and mPET. We know that a limited number of studies have examined relation of between thermal perception and thermal comfort for pedestrian on the move. And pointed that the existing biometeorological methods misrepresent the actual exposure of pedestrian on the move. For that purpose, Vasilikou and Nikolopoulou, 2020, introduced thermal walks to capture dynamic sensation in complex environment. So this method of dynamic thermal walks are evaluating the thermal walks and taking into consideration continuous real-time changes in the thermal environment. Yet, most of the study indices are PET and UTCI, while a few studies use the mPET index. The methodology of static thermal perception studies based usually on fixed meteorological system sites, stations. They collect data of microscale environment, plaza parks, and so. They are usually snapshots of certain time of the day, of the year, or season. And the outcome is that these studies capture how the built environment and microclimatic conditions at a given point affect perceived thermal comfort. On the other hand, the dynamic walk thermal research studies, they focus on mobile microclimatic measurements. They take data from linear route through the city, sequential moment by moment data. And the outcome is that they reveal people thermal sensation as they move in an urban complex environment. We can see like what is it like in the street and how it looks like in a boulevard, in a shaded area in the same city at the same time. If we go over the advantage or limitations of the two systems, the static research is stationary. It takes snapshots. It uses a fixed sensor or fixed stations. And its strength is that it has a good linkage with the local climate zone, but the limitation that it misses dynamic of movements. The dynamic walks studies are moving. They take sequential data, wearable and mobile sensors that are used during the route, so they can reflect the comfort of the people transition. And the limitation of this system is that there are more complex logistics and a smaller sample size. Most of the used indices for dynamic thermal walks are PET and UTCI, as we said, and there are a few studies that use the mPET index. However, PET and UTCI misrepresent the exposure, the actual exposure. So to overcome these limitations, scholars introduced mPET, DPET, and transient UTCI. However, they are not so common in use yet. And this study focused on the mPET, since it's more commonly used till now. Now I will quickly go over the difference between PET and mPET. The PET was introduced by OPE 1999 based on MEMI. And the strengths of this index, it's good for comparison across climate and cities. Its limitation of the PET is that it oversimplifies clothing activity, less accurate at extreme climate at hot and dry, hot, humid, and hot and dry. And it made the vary from actual TSV. On the other hand, the mPET, which was introduced by Chen and Matzarkis in 2018, is an enhanced PET using multimodal node. It takes clothing insulation dynamics. It strikes that it's closer to the TSV in hot, humid, transient climates. The limitation of the mPET are that it's more complicated to computate it. It's still not widely applied yet, and assumed reference activity unless adjusted. The objective of this study are to examine the relation between pedestrians' thermal sensation vote, MTSV, corresponding to PET and mPET values recording along a walking route, and to evaluate the overall suitability of PET and mPET in predictive indices of pedestrian thermal sensation during dynamic thermal walks. And finally, to determine which of the indices, PET or mPET, provides the most accurate prediction for pedestrian real-time thermal sensation during continuous movement in a complex environment. The research methodology was based on observations. The research units were 2 commercial streets, 2 side streets, and 2 boulevards in the city. Data collected by fixed monitoring stations at the fixed positions and thermal walks, human thermal questionnaire survey, and data analysis, calculation of PET and mPET versus the TSV of the participants. So the research units you can see now in the city center of Tel Aviv. It's in Israeli Mediterranean climate. 6 different walking groups, commercial routes, side streets, and 2 boulevards. And the field campaigns were conducted during summer, few days in the summer and days in the winter. So as we said, the microclimate measurements collected data by fixed meteorological stations, which plays in the investigated streets or boulevard, simultaneously measuring air temperature, humidity, wind speed, and so. Plus thermal walks, environmental monitor that took place simultaneously with the fixed data collection during the thermal walks with walking groups of 6 to 10 students to evaluate the objective data and subjective thermal perception of the respondents, of the members of the group. The total of the votes were 1,440. Measurement took place at 4 checkpoints along each route with using Kestrel heat stressor trackers. And thermal conditions were calculated, PET and mPET indexed by RayMan Pro 3.1. And we can see how it looked, 3 examples of commercial street with the 4 points along the route, side street, 4 points, the red points along the route. You can see that this route starts inside the park. The first point of checkpoint is the park, but it goes through Street Canyon and the boulevard, all along the boulevard, 4 points. Okay, now I'll go quickly through the results of this, the data that we collected. This shows the PET conditions that were collected by the fixed meteorological stations in the summer. In the winter, we can see 3 different sites, 1 commercial street, 1 boulevard, and side street. And this shows the PET and mPET values along the walking routes. It is in midday and based on metabolism 250 in the summer and in the winter. PET, we can see that the PET values are higher on the scale than the PET. The mPET values are higher on the. Now I will concentrate on the relation between thermal sensation vote and PET, comparing to the mPET. In the summer, you can see that and in the winter, the mPET shows the better correlation, better relation. The values are higher, and means that the sensitivity of the mPET is sorry. Yes, the sensitivity is better. In comparison, we can see one of the streets in the side street with the walking route in comparison to the fixed stations, which was also in 2 locations, one in a park and in a street. And we have to understand that this research was based on much bigger sample size. But still, we see that the difference between this is PET only, and we see the difference between the mPET and PET. Okay, so the findings of the research are that in most of the cases, mPET shows higher R² values in comparison to PET. It indicates that mPET better explains the variation in thermal sensation volt across changing thermal conditions. The slopes are generally steeper for mPET than PET, suggests that mPET is more sensitive to participants' subjective thermal response during their walk. And this phenomenon was observed also in previous studies. PET tends to underestimate the effect of metabolism and accumulative response during the thermal walks. To conclude, we would say that mPET outperforms PET in capturing dynamic real-world walking experience, and the mPET better matches subjective thermal sensation and perception. Thank you.